Welcome to Gambler 007. Today I will be presenting Java 8 feature, that is parallel stream. Let me start quickly. See here, coming to this particular feature, it is introduced in Java 8. And this particular feature, it will help you when you are having massive data set and you wanted to perform and you wanted to utilize the CPU. Okay, there are a few more factors on what basis you can use the parallel stream, but let me start quickly with a small snippet of code. I think you know what is stream and how we can use this stream in Java 8. And based on this knowledge, I am actually considering and going further. You see here, this is the snippet of code where you see here with the array. So that's why I taken very simple code, not even taken the array list, I just taking the array and putting few elements. I think here it is a 10 elements. And after this 10 numbers, what I am doing, I am converting that array into stream. And once this is converted to stream, these all are the integer numbers. We are having a int stream. That's how I converted to int stream. Once it is converted to int stream, then just you are playing with the stream. So what we are doing, just we are taking one by one and just printing. This is what we are doing, but we are also printing the thread name, which particular thread is executing this particular snippet of code. And you see next it is parallel stream, and it is just using parallel. If you are using parallel of this particular method, it will convert the sequential stream to parallel stream. It's a pretty easy to opt the parallel stream, but there are complications when you don't find the suitable situation. Anyway, that will be discussed in coming slides. For now, how you will be writing the stream, how you are converting the int array to stream, then how you are executing the sequence stream, and how you can able to execute the same snippet of same array into parallel stream. So this is how the program written. Let me summarize. Here we are taking array, that array converting into stream, then printing those array elements. And in next level and in next section, we are converting the converted into stream. Second, converting into the parallel stream. Once we are converted to parallel stream, it's the same again printing the numbers. This is what we are doing. Just taking, just printing. One is in sequence stream, another one is parallel stream. That is more about this particular snippet of code. And you see here the output. In the sequence stream, you see 1 to 10 in. It's like 1 by 1, it is printing 1, 2, 3, 4, 5, and which particular thread is executed, main thread. Whereas in parallel stream, you see it's a random. There are many threads created. There are for giant pool, common pool. It's like a worker 1, 2, 3. It's a random. It is not sequence. Which particular thread, which particular element it is executing. No sequence. It will take randomly, and it will first how this particular parallel stream will execute. First, it will prepare internally. Okay, it will divide into multiple threads, and randomly it will pick the collection, and it will split the collection, and it will start executing. This is why you could see here. For that particular reason, I written this particular program, and you see here how this particular parallel stream works. It's not a sequence. And in case if you are looking for sequence, then this won't be suitable. And you have to do little bit R&D before considering the parallel stream. Parallel stream is not for sequence. If you want sequence, use sequence stream. And the parallel, it will take and it will execute with multiple threads. It's not one thread will be executing your program. And when you will consider this, should you always use parallel stream? I could say no, not at all. Don't use blindly without knowing anything. That's why I'm just giving here the hint. And if you notice the output, the main thread is doing all the work in case of sequential stream, whereas parallel stream create port giant pool and it instantiated via static, through port giant pool dot common pool. This common pool by default it will be created, and once this parallel stream take the benefit of all available CPUs and processes, the task is in parallel. If number of tasks exceed number of cores, then remain task wait for currently running task to complete. It's like, even though you are having 5 processors and it will try to divide multiple threads, then if it reaches the limit, then it will, there is no option to create more threads. That's why this is how it will completely utilize this CPU availability. Then once it is reached the limit and still there is a little more work to complete, in those cases it will wait to complete one of the thread, then it will take that particular task to perform. And you see here, this is why I'm saying, even though it is a cool feature, but you should be no, you should not use. It is easy to convert sequence to parallel, and there are negative impacts. Parallel stream has much higher overhead than sequence stream and takes good amount of time to coordinate between threads. And when to use the parallel stream? And if you are using parallel stream, then you have to take few points. You see here, you have a large data set to process. It should be large data set. Then only you consider using parallel stream. That is the primary. And the second thing is, you should be knowing it internally uses core giant pool. And the third is, when you are doing this, you should it's like an internally it will submit the execution to core giant pool. And what it should be done, as it will split as a task, and whatever collection you are choosing, that should be able to splittable. For example, you take array list. Array list is very easy to split. Very easy to split. How it will split? For example, if you are having 10 lakh records in array list, or you consider 5 lakh records or 2 lakh records in one collection, easily it can split however it wants. Like take first 100, 200, 500, however it is, it will take it. Easily it will split. But for example, if you use a linked list, it's very hard to split. Does not perform very well in most of the cases. Linked list has a problem. You cannot split that easily because of the nature of head and tail. It's not that easy. And you are actually suffering from the performance issues. And so if you are having performance problems, then you can start thinking about parallel stream. Mean to say performance problem. Most probably you are having huge data set, huge data to deal. And the next thing is, you need to make sure that all shared resources between threads need to be synchronized. And in case if there is something, there is a shared resource, and if that shared resource, as it is executing in the parallel stream, and there are multiple threads, and there is some common resource which should be used among them, then you have to make sure that particular common resource is synchronized properly. Otherwise, it might produce unexpected results. Instead of giving 10, if you are giving 20 or 100, then it will be a problem. So you should make sure it is synchronized among when there is a common resource. And how you will measure the parallel stream when you are taking this? This is the formula. I would recommend to go through once. What is this? And Q, number of items in the data set. Q is the amount of work for item. how much work for item it will take. So that is n into q is greater than 10,000. It means if you have a large number of data sets and less work for item, for example, some are average, like maybe modular, whatever it is. Parallelism might help you run program faster and vice versa is also true. So if you have less number of data sets and more work for item, doing some computational work, then also parallelism might help you in achieving the result faster. So means if there is something that should be calculated or manipulating, there is something, then you can go for parallel, parallel program. Here there is a performance comparison, how you can compare the CPU utilization between the sequence and the parallel stream. This is the program. You see here what we are doing. Let's consider here. I wanted to do some. What I am doing here, just I am taking the time, how much time it is taking, how much time. So when we are starting this particular thread, then we are taking the array. The size is, you see here, it's 1 lakh. And we are adding to the data. And what is this data? This is a integer list, array list. And once we are having this array list, what we are doing, this data we are converting into this stream. This is data.stream of. Once it is, the collection is converted to stream, then it is a matter of, just let me check, there is a battery, 25 minutes to go, let me, okay, that's okay, I think it can be done. Okay, and here you see here, once it is converted to stream, then we are performing the maths operation, that is square root of. And once we are having this square root of, again we wanted to perform some computation. Then we wanted to reduce. This is how I want sum. And once I'm having this sum, just I'm printing here. And this is n time I am printing here. This is how you can calculate how much time, n time minus current time. And I am converting into the minutes. This is how it is. This is about the sequence. And you see here how much time it took. It took 6 minutes to complete this particular program. And whereas this is how the CPU utilization. The CPU utilization is once it is taking little. And you see here, this is the once you see it's like same piece of code. Just you add a parallel and especially at the line 16. You see here what is the line 16 here. Here instead of stream, just you convert to parallel stream. And once you are having parallel stream, and if you execute the program, it can be done in 3 minutes. How you see the output, the CPU history. In middle, it's like the end of that. There, the program is executed with the parallel stream, and this is utilized maximum utilization of the CPU. See here, the utilization of the CPU is never maximum, but you see here, when the program executed in the parallel stream, it utilized maximum CPU utilization. And so once you are able to do parallel stream, and there are complications. If you don't use custom thread pool, what will happen? The common pool it will take, and how many processors there doesn't matter. It will go and utilize. So the problem you will encounter when you are having one more parallel stream in the same program, or maybe in the same project. If you are having multiple parallel streams, then it will be a problem. So for that, what you have to do, you have to implement your own customized port giant pool. So that's how you have to specify the parallelism. How many? It's like you have to specify the value of parallelism. Then only it will work better. And this is what I am saying in this particular slide. And you see here, once you are done the port giant pool, here I am giving the 5, for example, and this 5, once I define port giant pool is 5, the parallelism is 5, and I am writing here data.parallel stream, save program, And just I am returning to the callable, and this callable just I am submitting to the you see here I am submitting to the put giant pool dot submit. Then you just pass this callable statement, and you just do get. This is how internally this will be initiated the parallel stream, and it will limit to the this 5. And if you wanted to see the output, how it will be, yes, I have not recorded here. It will use only those particular 5 threads, and it will complete the program. And whenever there is some problems, so there is a try catch here, interrupted exception or execution exception. That's all. This is about more about parallel stream. Of course, you can execute and you can see the result. And don't forget, when you are using the parallel stream, do not forget the mechanism, when to use, how to use. And one more point, if you are having stateful things part of your parallelism, parallel stream, then it will be a problem in our data set internally. For example, in piece of, for example, here, if there is something, some stateful, then that will be a problem. Just you keep note of that. And especially you are using the lambda and all, and if there is a stateful operation, it will be a problem. And one more thing is, if you are expecting any sequential steps, no, it won't perform sequential steps. That is also very, very important. And this is how it is. And that's all about parallel stream. Thank you very much. Thanks for watching the video. And in case if you like this video, please like, comment, subscribe, and share for more updates.